Hello students. So let's try to solve one more problem from JEST 2021 examination. And in this problem, this is from the part B and question number 12. The Lagrangian of a system is given and we have to write the Hamilton's equation of motion. So when we have to write Hamilton's equation of motion, first we have to convert this Lagrangian into Hamiltonian, and then we can go for Hamilton's equation of motion. And we also see that when we are changing x dot x to y, there is not any change in Lagrangian. So obviously, whatever be the equation of motion of x, that will be the exactly equation of motion of y. So we have to only solve for the x, then we can easily predict for the y, because this is a typically symmetric in the exchange of x and y. Anyway, so but we can solve it completely. So let's try to go for Hamiltonian of a system. So here x and y are generalized coordinate. So Hamiltonian of a system is x dot px plus y dot py minus Lagrangian, and this value is x dot px plus y dot py minus half m x dot y dot plus half m omega square xy. So we have to replace x dot y dot, and similarly here x dot y dot, such that Hamiltonian will function of generalized coordinate and generalized momentum. So here we can use this particular thing. So del L upon del x dot is equal to px, and which is equal to half m y dot. So y dot is equal to 2 px upon m. Similarly, we can just go for del L upon del y dot is equal to py, and that value is half m x dot. And here x dot is equal to again 2 py upon m. So now we can put all this value here such that we can get x dot is equal to 2 times py upon m. So py px upon m plus this term will be again 2 times px py upon m minus we have to go for half m 2 times py upon m into 2 times px upon m plus we have to go for half m omega square xy. So we can easily see that this is cancel out, and this will be 4 times px py upon m minus 2 times px py upon m. So this value is equal to 2 times px py upon m plus half m omega square xy. So this is my Hamiltonian. And now we have to go for Hamiltonian equation of motion. So we have to write the 4 equation of motion. So first del h upon del x is equal to minus px dot. So when we are just going for del h upon del x is equal to minus px dot, that means we have half m omega square y is equal to minus px dot. This is one equation. And second equation is similarly, we have del h upon del y is equal to minus py dot. So we have half m omega square x is equal to minus py dot. So this is my second equation. The third equation is del h upon del px is equal to x dot. So from here we have 2 times py upon m is equal to x dot, and similarly we have fourth equation. So I am writing the fourth equation, del h upon del py is equal to y dot, and from here we have 2 px upon m is equal to y dot. So from here you can easily see that option number 1 is the correct one. So we can just match and we can reorganize all this thing and we can write this thing in a correct manner. And you can just solve only for x, one for x, one another, and then another thing will be the same for the y. Because if you are changing x to y, the Lagrangian is not going to change. The Hamiltonian is not going to change. So this is the correct answer for the Hamiltonian equation of motion. So you can just go for this. So answer A is the correct one. Thank you.